Hello. In today's lesson, I'm going to solve a set of simultaneous equations using the three different methods that we've been learning so far. So the first method that we learned was a graphical method. And here on your screen, you can see the first of the simultaneous equations. 3x plus 4y is 27. So to sketch this on a graph, we need to have 2 points, and then we join the points. So the first point I'm going to look for is the one that has x equal to 0 in it. So if I put 0 into this equation, what do I get for y? So that's what I'm trying to figure out. So I have 3 zeros instead of x, and I add 4 y's to that, I should get 27. So 3 zeros is 0. So that leaves me with 4 y's is 27. So I need to divide both sides by 4 to get rid of that 4, so I have just 1y. So that will leave me with 1y is 27 divided by 4, which is 6 3/4 or 6.75. So when I put 0 into that equation, y came out to be 6.75. So that gives me my first point, which is x first, 0, and then y, 6.75. So I need to do the same now with a different point. So instead of starting with x is 0, I'm going to start with y is 0. Put that into the equation and figure out which x belongs with that. So if I put 3 x's and add to that 4 zeros, 4 y's, I should still get 27. 4 zeros is 0, so I can ignore it. So 3x is 27. Divide both sides by 3. 3x divided by 3 is just 1x, and 27 divided by 3 is 9. So that's given me my second point, which is 9 and 0. So these pairs of points both fit into this equation. 3x plus 4y is 27. There's lots and lots of other points we could have come up with, but all we need is 2. So I want to sketch the graph for what would it look like if I put these 2 points on a graph. So it's just a rough sketch, so it doesn't need to be perfect at all. So we put down our x and y axes, x in the horizontal, y going vertical. First point is 0 on the x, and then up to 6.75 on the y. So I'm just going to guess that's about there somewhere, 6.75. That's where we have 1 point. And the other one is 9 on the x and 0 on the y, so about here somewhere. I'm just going to put a point there. And then what we'd do is we'd take our ruler, if we were doing this correctly. We're only sketching, so it doesn't have to be perfect. And we just join those dots with a straight line. So that's what this line, or this equation, would look like if we put it onto the graph. So I'm going to do the same now with our second of our simultaneous equations. So our second equation is this one. Minus 3x plus y is 18. And again, we're looking for 2 points. So we can pick the point where x is 0 to begin with. So we have minus 3 zeros plus y has got to give us 18 this time. Minus 3 times 0 is 0, so we've just got y is 18. So that's the first point for this line. So this is point 0, 18. Then we're looking for the second point, so I'm going to use y is 0 for the second point. So I have 3 x's, or minus 3 x's, plus 0 gives me 18. So minus 3 x's must be 18. I just want 1x, not minus 3 x's, so I need to divide by minus 3 on both sides. Remember to balance your equation. So that'll give me 1x, and 18 divided by minus 3, that's a positive number divided by a negative number. It's going to give me a negative answer, so minus 6. So this time our point is minus 6, 0. So again, we're going to sketch this diagram So we need an x and y axes, but remember this time our x needs to go to -6. So we actually need to have going across over here to about -6, 0. And we need to go up on our y-axis all the way up to 18, so up quite high up to 18 on our y-axis. So 0, 18. And then we'd just join those points with a straight line, and that's what that line looks like. So these are our two lines. We've got one that's going up when you read it from left to right, and our first line that we came up with is falling when you read it from left to right. Now these are simultaneous equations, so there's lots of points fit onto this line and there's lots of points fit onto this line. Okay, but what we're looking for is the one point which is on both of those lines. So we actually need to put the two lines on the same graph. So I've got my two lines here and I actually want to put the two of them on the same graph and try to figure out which point would be on the two graphs. So I'm just going to roughly draw in here the two of them on the same graph. So the one goes kind of like this and the other one goes, let's see, kind of like that. So the point we're looking for is the point where these two meet. That's the point of intersection, or shorthand point of intersection. That's that point in there. Okay, and if we put this onto actual graph paper, we'll be able to figure out what that point actually is. So that's what I'm going to do now, but I'm not going to actually draw it on graph paper. I'm going to show you how to do it online. So I have this web page here. You can go to this web page yourself. It's Desmos. So desmos.com, and it's a calculator that's online. And in the boxes over here, we can type in our equation. So one of our equations was 3x plus 4y is equal to 27. And you can see the equation is here. And the line has been drawn for you and it's been graphed for you. So that's the line that was falling like we expected. The other line then I can type in just underneath here. So it was minus 3x plus y equals 18. And you can see the equation is here and the line has been drawn for us on the graph. And remember, we're looking for the point where the two lines cross over, so we're looking for that point in the middle there where they intersect. If I just click on that point, it tells me that's the point minus 39, which is the answer that we got if we'd have drawn it out on the graph ourselves. Okay, so that's our first method when we're solving these equations using a graphical method and we're looking for the point of intersection. So we know now our answer is minus 39, but we're doing that just from a graph. So ideally what we want to do is use algebra to find that and to prove that it's correct. So we have two algebraic methods so far that we've learned, and I'm going to start with the first one, which is the elimination method. So these are my two equations and I have labeled them. I have given them the names 1 and 2, so equation 1 and 2, and I'm looking to see my coefficients. And in this case I can see the coefficient of x is 3 in the first equation and minus 3 in the second equation, which is perfect. That's ideal. That's exactly what we're looking for. So what I need to do is add these two equations together. So I'm going to add them just like I was doing a regular math sum. And I've got 3x, and I've got to take away 3x, that gives me 0 x's. I have 4y plus y, that's 5 y's. And I have 27 plus 18, which is 45. So 0 x's plus 5y is 45. So 0 x's is 0. I can eliminate my x's, they're gone. That's why it's called the elimination method, because I don't have any x's anymore. I've eliminated them. So I now have 5y is 45. I want to figure out what 1y is, so I need to divide by 5 on both sides. And that will give me 1y is equal to 45 divided by 5 is 9. So what I need to do with that 9 is substitute it back into one of these two equations that I started with. So I choose one of those equations and I substitute y is 9 back into that equation. So I'm going to go with equation 1, which said 3x's plus 4y's. So I've got 4, and instead of y, I'm going to put in that 9. So this 9 is going in there instead of y. Remember, when you substitute, you put brackets around the number that you're substituting in. So 3x plus 4y is 27 in equation 1. So I need to do this equation and try to figure out the answer. Just move my board up a little bit. Okay. So 3x plus 4 9s, so 4 multiplied by 9 is 36, is equal to 27. So now I want to get x all by itself, so I need to get rid of this plus 36, so I need a minus 36 on both sides of the equations. So that will give me 3x is 36 minus 36 is 0, that's gone. So on the other side then I have 27 minus 36, which is minus 9. I need to divide both sides now by 3 to get rid of the 3 because I just want 1x, and that will leave me with 1x is equal to minus 9 divided by 3 is minus 3. So our point of intersection is our x value first, which was minus 3, and the y value, which is 9, which is the same value that we got when we graphed the two equations. So that's using our elimination method. I'm now going to use the substitution method and do the same thing, but with the substitution method. So again, I have my two equations and I have labeled them. Now to use the substitution method, I really want to have one of the equations in the form where y equals mx plus c. Okay, and neither of my equations are in that form. None of them start with y equals. What they've got is x's mixed up with coefficients, and there is one equation though that has this y by itself without a coefficient. Or really the coefficient is 1. So this equation 2, is the one I'm going to change and make it look like y equals mx plus c. So I want the y and I want the equals. I don't want the minus 3x to be over here, so I need to subtract. I need to add 3x to get rid of a minus 3x. And I need to do that to both sides of the equation. And remember, I want my x's to come before my numbers, so I'm going to plug it in here, just here in front of the number. So what I end up with is minus 3x plus 3x is gone. I have my y equals, which is what I wanted. On the other side, I have the 3x, which I plugged in there. And I've got 18, and it's a positive 18. So I now have my equation in the right format. So this is equation 2, but it's just been rearranged so that it's in the right format for me to use for the substitution method. Okay. So what I want to do now is I take the other equation. So equation 1 was the other one. So I'm just going to write down equation 1 here, and it's 3x's plus 4y's. But instead of writing 4y's, I'm going to substitute. I'm going to take all of this for the y and plug it in here instead. So there's my 4y's. I can do that because y is the same as that. So 3x plus 4y is 27. So now I've got a new equation. Y is gone, and I've just got x's in my equation. But I do have to distribute this 4. I need to distribute it to the 3x, and I need to distribute it to the 18, so I can get rid of the brackets. So we have our 3x, we have the 4 distributed to the 3x inside the bracket, and we have 4 distributed to the 18, which was inside the bracket, and all of that's equal to 27. So that gives us 3x plus 4 multiplied by 3x is 12x. 4 multiplied by 18 is 72, is equal to 27. So now we need to gather our like terms. So we have 3x and 12x here, which we can combine into 15x. And we want to gather our constants to the other side of the equal sign. So we need to move this 72 with a minus 72 on both sides. 72 minus 72 is 0, and on the other side we have 27 minus 72, which is minus 45. So we need to get 1x, so we divide both sides of the equation here by 15. That will leave us with 1x is equal to minus 45 divided by 15, which is minus 3. So now what we need to do is substitute it again. So we substituted a little bit earlier here when we took this version of 3x plus 18 instead of y and substituted into equation 1. We now need to take our value that we found for x and substitute it back into the equation that we had, our y equals mx plus c equation. So we now have y is equal to 3x's, but x now we've figured out is minus 3, so we're substituting in minus 3. So 3x's plus 18. So y is 3 times minus 3 is minus 9 plus 18. And minus 9 plus 18 is 9. So we have our point of intersection is the x value minus 3 and the y value plus 9, and that's our answer.